Okay, so we're going to do section 2.4 homework problem, question number 9, and then also discuss about question number 10 and 11. So for the question number 9, as you can see here, find the x values at which f is not continuous. If there are any discontinuities, determine whether they are removable or, use k as an arbitrary integer. Enter your answer as a common comma separated list. If an answer does not exist, enter dne. So for this function, we need to find out the removable discontinuity. And as you can already see that there is none. And then non-removable discontinuity, uh, the answer is, as you can see, it's an integer k. I'm going to explain you first what does it mean. It's a double bracket function, so it takes anything lower than any integer lower, an integer lower than that value. So the meaning of that is, if you have double bracket of negative 1.5, you try to find out what integer comes lower than negative 1.5. If you look at the number line, negative 2 is the integer which is just less than negative 1.5. Let's say instead of negative, if you are talking about positive 1.5, what is the integer which is just less than 1.5, which is 1. So by using this fact, if you try to plot the graph, this is the graph you're going to see for this function. And as you can see here, removable discontinuity means where the function is discontinuous and undefined at that point. That's called removable discontinuity. But in this case, yes, there is a discontinuity at integers, but that's not removable. So the answer for the first part is dne, does not exist. And answer for the second part, these points where it's a discontinued, for example at 0 or 1 or 2 or 3 or 4 or negative 1 and keep going on the left side, they are the integers. And that's the reason we are using the value k, because at k, at any integers including 0, the function has a non-removable discontinuity. That's the definition of non-removable discontinuity. They have the jump, that's a discontinuous, and it's a non-removable. Okay, so that's question number 9. Let's go to question number 10. Find a constant a such that the function is continuous on the entire real number line. So you need to find out the value of a such that this is continuous at entire real number. So remember, the function is called continuous at any point when the left hand limit and right hand limit of the function is same, and that is equal to the limit of the function. So when I try to find the limit of this function when x approaches to a, so remember, we don't know what is a, but the value is given for the a, so we need to find out the value of a. And since this is a continuous at a, so what is the value of the function at a? It's 4. That's supposed to be equal to the limit of the function when you either approach from the left or from the right. For that, you can use the first part for finding the limit. So what is the limit of this function when x approaches to a? Can be calculated by using this expression on the top. Remember, this top value is when x is not equal to a. So if you try to simplify this expression, this is x minus a times x plus a, and there is x minus a on the denominator already. Since x is not equal to a here in this expression, so you can cancel this too, and when x approaches to a, this value becomes a plus a, because you have to replace this x by a. That's actually 2a. So to be a continuous function, for this g of x to be a continuous, this limit has to be equal to 4, because the limit of the function is supposed to be equal to the value of the function. That's the definition of continuity. So that's 2a has to be equal to 4. And if you solve for a, that is actually 2. That's the reason the answer is 2. Question number 11. Find the composite function f g of x. So just go back here. This is from college algebra. Wherever you see this x, 10, instead of x, we are trying to replace this by g of x. So wherever you see x is replaced by g of x, the value of g of x, which in this case it's x over 4. That's the reason the composition function is 10x over 4. So where this function is discontinuous, to find out that thing, you need to know the what is this called? Graph of 10x over 4. Wherever you see discontinuity for the graph of 10x over 4, that is from trigonometry, The function, this tangent function is not continuous. The composite function is not continuous as f has domain restriction. If you look at the graph of tangent function, there is a domain restriction. I can just go here and then I can just Google graph 10x. That's from what is that called? Trigonometry. So as you can see here, this is not completely continuous. There is a restriction. That's the reason. What is that? The composite function is not continuous as f has a domain restriction. Okay. So what is the domain restriction? Wherever this expression here, this is equal to this value, find the x values at which h is not continuous. Whenever this value is equal to this 2 pi times 2k plus 1, and how I'm getting that? By going to the domain of tangent function. You see that? The tangent function is not continuous at pi over 2, 3 pi over 2, which is n times pi over 2, where n is, what is that called? Odd number. So you just replace that by the expression you have here, which in our case, what is that? It's a pi over 4. Okay. Find the x values, if any, at which h, which is this function, is not continuous. So what is the domain of 10x over 4? So these are the points where the 10x over 4 is not continuous, and that can be found from here, this domain of tangent function. Hopefully you understood that. Otherwise, go to trigonometry and find out the domain of the 10x, replace that x by x over 4 and solve for x, and that is what you're going to get this answer.